So let's start with acetic acid again. Good standard. We've got acetic acid. It breaks up into H plus and acetate, AC minus. So we got our acid over on the left. We've got our base over on the right. We'll use 1 liter solution just so our molarity equals our moles. And we'll say we have 0.10 mole of the acid and 0.05 mole, well, let's give an extra 0.05 mole of the base. Now normally this would create some amount of H+. Remember our Ka is 1.8 times 10 to the minus 5 for acetate. So we could solve the pH for this real quick. This starts pH. It's going to be our Ka. It's going to equal H plus 0.05 for the base, 0.10 for the acid. Plug in the Ka we just had, solve for our H plus. So it's going to be 3.6 times 10 to the minus 5, which gives us a pH of 4.44. So we have a starting solution. It has a pH. And then we're going to mess with it. We're going to add 0.008 mole of NaOH. We're going to add a strong base. Well, what is that going to do to our mixture? If I have NaOH and AC minus, nothing can happen. AC minus has already given away its proton. It doesn't have any more to give away. The base just bounces off and does nothing. But if I have an HAC, when it hits it, it consumes the H+. So when a strong base gets added to a buffer solution, what's going to happen is we're going to lose some of our weak acid. So we're going to lose 0.008 moles of the weak acid. Well, if the acid loses H+, it is the base. It becomes the conjugate base. So we're going to create just as much conjugate base. And so this is reverse of what we saw with last video with the HCl. Strong base consumes weak acid, creates weak base. So this is kind of opposite what we saw last time. Last time we added HCl and it got rid of the weak base. This time we're adding a strong base, sodium hydroxide, and it's getting rid of the weak acid. Where will that leave us? Well, for our acetic acid, 0.10 minus 0.008, 0.092. For our AC minus, it was 0.05, and we're going to add 0.008 for 0.0058. Now we said this was all in 1 liter, so our moles are our molarity at that point. And so I can set this up with the Ka, it's going to equal the H plus, 0.058 for the base, and 0.092 for the acid. So Ka 1.8 times 10 to the minus 5. H plus in this case, that will equal 2.86 times 10 to the minus 5. So previously, bring down on the side here, at the start, we had a pH of 3.6. Now it's 2.8 for our concentration, our concentration of H+. Our pH then is 4.54 for our new one. So we changed a little bit. We're a little bit higher. Our final pH is a little bit larger. And remember that a larger pH is less acidic. It's more basic. We added some strong base and we got more basic, but not extremely basic. And the same idea with adding the strong acid from before. Normally, if you add it to pure water, you massively change the pH. But if there is a mixture of a weak acid-base combination, this prevents it. Because what really happened is we just slightly shifted the amounts of our weak acid and weak base. And so the pH only shifted slightly as we adjust those amounts.